Welcome to 3D from Nothing, powered by Metalmite, the show where you learn all about 3D printing and additive technology. I'm your host, Tom Gendich. Metalmite is a full-service machine shop that specializes in 5 and 6-axis CNC machining, CNC grinding, wire EDM, and 3D printing. We're a 50-plus-year-old corporation started by my father, Michael Gendich III. I took over as CEO in 2009, continuing the manufacturing legacy today as a third-generation owner. In these programs, you'll learn what kinds of printers are out there, what kinds of material you can print on, who's using these printers, what kinds of things you should be looking at printing, as well as hearing from experts in the field through interviews that we'll be conducting. As always, you can go to our website, 3dfromnothing.com. You can get free giveaways, learn more about what we're doing, about the names, the name that comes from my father, where he said at some point we'll make parts out of nothing. And today we're doing just that with 3D printing and additive technology. Today we have a special treat for our listeners, Metalmite's very own Patrick Davidson. Patrick had been a customer of Metalmite's for 14 years at 2 different organizations. In 2018, we had the opportunity to have him join our leadership team as the Vice President of Operations. Patrick has a rich history of leadership development and strategic planning. As a former math teacher, both to high schoolers and Villanova University, Patrick uses his gifts for mathematics to teach others and understand the environment through math. Today, Patrick's leading Metalmite in a strategic way to create a cohesive team using a balanced scorecard and a winning plan. We're going to dive into this plan today to understand his processes a little better. Then we're going to discuss some 3D printing and how it's influencing the processes at Metalmite and for our customers. Patrick, welcome to our show.
Thanks, Tom. Glad to be here.
Yeah, we're excited. I know you're very passionate about both Metalmite and about strategic initiatives. I wanted you to be able to share with our audience today a little bit about some of that.
Sure. One of the things that I've done over the years is a lot of self-reflection and self-understanding. One of the things I did many years ago is take the StrengthsFinder 2.0 assessment. It tells you what your top 5 strengths are, the things that you do well naturally. And strategic is actually my number 2. Futuristic and strategic are my top 2. So when it comes to strategic planning and futuristic thinking, those are things that come very naturally to me. In addition, I've been in many organizations that have great hearts and great intent. And yet, when you look at the things that people are working on every day, it tends to not be the most strategic, most important things that they want to be working on. The great story told by Stephen Covey in the 7 Habits of Highly Effective Leaders, where he talks about the professor who puts the glass jar on the podium in front of his students, and he takes out 3 big rocks and he puts them into the jar until the last one comes to the top. And he says, "Now, is the jar full?" And the students say, "Yes." And then he reaches underneath the podium and grabs a bag of gravel and pours it in, and all the gravel fills in the spaces around the rocks. He says, "Now is it full?" And they pause and they say, "We think so." And then he reaches underneath and grabs a pail of sand and pours it in all around the gravel until it fills up. And they said, "Is it full?" And they said, "Probably not." He said, "You're learning." And he grabs a pitcher of water and pours it in until it's right to the top. And he says, "What's the moral of the story?" And all of these fast driving, hard going students said, "There's always room for more. You can always squeeze more in." And he looked at them and he said, "No, the moral of the story is if you don't put the big rocks in first, they won't fit." And so what we need to remember is there's always going to be the gravel and the sand of our work lives. There's always going to be those tasks and things that we have to get done. But if we put those into the jar first, if we put those into our day first and our schedule first, they don't leave room for the big rocks, the most strategic things that will align with getting us to where we really want to go. And so that's why I'm super passionate about strategic planning, because it helps us remember what the big rocks are and keep the big things first.
Yeah, that's fantastic. And it fits perfectly because just as the big rocks keep us going where we need to go at Metalmite, I shared in the first episode a little bit about our just cause. And that is to help create products that help people move in the direction they need to go. And again, we've given a lot of time and thought, and specifically you and I have spent time with our leadership team over the last couple of years talking about our why and what gets us out of bed. I wanted to spend a minute. The last episode, people understood or heard from me what our just cause mission, vision, and then our core values were. but I wanted to spend a little time with kind of understanding the why behind it, going behind the curtain, if you will. Can you talk a little bit about where these ideas come from? Or are you just a genius that came up with it, or are there some other people that led us in that direction?
No, I'm no genius. As you indicated at the outset, I'm a mathematician at heart, so I like rules and regulations. But yeah, no, in fact, Simon Sinek is probably the one that has written the most on it in the last decade, starting with his seminal work, Start With Why, and then Leaders Eat Last, and most recently, as of this time, his work on The Infinite Game, which is about the just cause and an infinite mindset. For those who have contributed, you've got Jim Collins, of course, in his work, Good to Great, talking about the BHAG, setting the course for that. Pat Lencioni and his 5 dysfunctions of a team and all of the things he's published. Even Brené Brown has really weighed in as a sociologist into the psychological and sociological implications of all of this. But at its heart, mission, the mission is why we exist. It's why we even get out of bed in the morning. It's the intrinsic reason we even exist as an organization. That's the mission, right? The why. The vision is it's where we're going, the direction we're headed. It's that true north. Every time you take out your compass, no matter what you're facing, the needle will go north. That's the vision. That's where we're headed. The core values are what make us us. As you know, at Metalmite, we're not the only machine shop in the world. We're not even the only additive shop in the world. There are lots of other facilities out there, but there are things that make Metalmite uniquely Metalmite. Those are our core values. They're how we do things here. So if the mission is the why and the vision is the where, the core values are the how. That's how we do things around here. And it's what makes us. They're the non-negotiables if you want to be a part of the Metalmite team. And then there's the just cause. And this is really getting a lot of treatment here recently. And that just cause is the thing that's bigger than even the mission at Metalmite. It's that thing that really is trying to change the world, if you will. It's a vision of what could be in the future that we may not even see in our lifetimes. And I say in our lifetimes, you're in my lifetimes, Tom, we may die trying, even Metalmite's lifetime. But the idea is it's so important and such a driver that we're going to move toward it with whatever energy and whatever time we have left. The simplest example to pick on here, we find ourselves in the month of February where we're recording this, is Martin Luther King. Right? His just cause was a world where people of all races had equal opportunity and were treated equally. He was going to, and unfortunately early did die trying, but the point was he wasn't sure if he would see that in his lifetime or in the next generation's lifetime, but it was so important, it was worth moving toward with all the energy and resources that he had.
Yeah, and I think that's important to step into, as I've heard Simon Sinek say, Martin Luther King gave the "I have a dream" speech, not the "I have a plan" speech. And I think as leaders, we also look at how do we get buy-in, right? How do we get our team to be excited about something? And I think if we come and say we have a 3-step plan and we'll increase sales by 10% at the end of the year, we'll see some yawns in the room, and we'll see some people tired. But I think to your point, if you set a vision far enough out and something that you couldn't even attain potentially in your lifetime, it gives a sort of a fixed point for, in sailing terms, it gives a point for someone to sail towards.
Exactly. And make no mistake about it, you have to have a plan, right? Failing to plan is planning to fail, as they say. So we all need to have one, of course. But to your point, a plan is not a motivator. A plan is how we achieve the thing that motivates us. And so that you talked about it, having that vision of where we want to go. That the mission is the thing, that why that literally gets us out of bed. When we roll over, what's the thing that when we think about, our eyes shoot open and we smile, literally as we're just waking up? Yeah, we're getting after that today. That's not the plan, doesn't get us out of bed that way, although we have one and it helps us get there. It's the why. It's the knowing that we're going to move toward fulfilling our just cause today.
And like I said, if we can talk a little bit about the BHAG, the big, hairy, audacious goal. I think Jim Collins originally started talking about that with the Good to Great series. You and I met several years ago and started developing this. But as I've shared this BHAG with a few people, the first response is always for somebody to either laugh at me or their eyes get really big. And I'm sure they're thinking, why are these guys wasting their time dreaming about growing a business 10 or 15 times larger than it already is? So can you talk a little bit about why we set such a large, seemingly unattainable goal out there?
Sure. First of all, in fairness to other people, most people have never been given the permission by anybody else or given themselves permission to really embrace what it is to go after what some would envision as a dream. They would say it's a dream. I would say with the plan and the process that we have, it's much more than that. And I can talk about here in a minute some examples where they became reality. But you have to be bold enough and also vulnerable enough to allow yourself to think big enough about something you don't yet know how to achieve. And for many of us who are competitors, many of us who are taught how to win, the idea of thinking about something we don't yet know how to do sounds not only audacious, but in some cases ridiculous. And so, in people's defense, many of us haven't been taught that it's okay to do that. Not only is it okay, it's necessary. I've had the opportunity to be at a few organizations that grew in those kind of multiples inside of 10 years. In one case, from revenue growing from 10 to 36 million in 28 months. In another case, growing from 18 million to 75 million in about 3.5 years. These kind of things that people wouldn't dream of. They wouldn't allow themselves to dream of because they don't think they're realistic. And a key part of it is exactly what we talked about. If you're willing to put the big, hairy, audacious goal out there, then you use so many of these tools and these gifts that we've been given to say, okay, if we wanted to be there in 10 years, if we allowed ourselves to think about that, we gave ourselves the freedom to dream like that, where would we need to be in 3 years in order to get there in 10? And now people start to say, I think if we were here, we could be there. All right, if we could get there, then where do we need to be in a year? So where would we need to be at the end of this year to get there in 3 years, to get there in 10 years? And ultimately, then you boil it down once more to say, okay, if we're going to get there at the end of this year, what are the priorities we have to have this quarter? And you do this each quarter of the year. And those are the big rocks. Those are the things you put into the jar first. Those are the things you focus on before the sand and the gravel of your day. And if you do that with discipline, time and time again, organizations have realized results that they never believed were possible because they first allowed themselves to dream. And then secondly, they used the plan.
Yeah, and I think that's the key right there, as I've had to explain it to a few people, why such a big, seemingly unattainable goal. And then you drill it down once they understand the why, because it is actually giving us our quarterly objectives. And as you and I know, we meet every week and discuss these, and we have, each of us personally has goals, and our other leaders have goals and objectives to hit on each quarter. As we get through a year, we're checking those boxes and seeing it. Recently, I heard a story from a preacher, and I just wanted to share it because it helped me understand the point of what we're doing about this. He was talking about, I think he had gone to Nepal on a mission trip with a group, and this guide said they needed to go to a certain destination, and they were hiking. He said it felt like hours, and he was exhausted, and the guys with him were exhausted, and they just couldn't wait to stop. The guide finally stopped, and he said to him, hey, are we there? Is this where we're going? Because they're all huffing and puffing and getting some water. And the guide smiled and said, no, let me show you. And he points off, and he says, if you can picture this in Nepal, there's mountains and it's not a lot of, roads and stuff. He points way off to the distance, and he says, do you see that blue speck on top of that mountain way over there? And everybody's squinting their eyes and looking. And he said, that's where we need to get to tonight. And the preacher said, there's no way. And there's bad weather coming. I'm exhausted. And the guide said, no, I'm taking you. That's where we need to go. And so they ended up doing it, and they accomplished it. They made it to this little blue shack before the bad weather and everything came in. And I thought that story was such a great picture for multiple reasons. One, they had a point off in the distance that seemed unattainable to a group that doesn't normally mountain climb and hike. But two, they had a person, a guide with them that had done this trip many times, and he knew they had to get there before evening. And so that he did in that case have a plan and a way to get there. So in a lot of ways, I feel spoiled at Metalmite because we have the in-house guide because you've been through this a couple times, you've seen it firsthand. And since our discussions with you, and I've had a few strangers that came into the facility and shared their stories that they also went from a smaller organization to 5 and 10 and even 15 times their size in a short period of time. And each of them had a different story of how that happened. It was customer driven, or it was work driven, or it was vision driven. But I think that's the point, right? We got to have a point off in the distance, and we got to have a way to get there.
Well, exactly. You illustrate in your example the exact things that are required. First of all, there was a vision of where we're going, the true north. It was way off in the distance, but we knew we needed to get there. So we knew the direction we needed to head. If this is a preacher and he's on, some kind of a mission, he had a why. He knew why it was so important to find a way to get there. So internally, he was motivated by a why. And then you needed to have a way, you needed to have a plan. And in this case, the preacher didn't have to own the plan because the guide owned the plan. And so he was able to delegate the actual plan to the guide, trusting that the guide knew where true north was and they were all headed in the same direction.
Exactly. Well, and as we've discussed many times, I think that's why you and I make a good pair, because I love the dream and I love the passion behind it. But when it comes to the plan, I think that's definitely your side of the table to make sure we're on task. So I think that's where the two of us worked well together. As we leave that section, I think we want to talk a little bit about 3D printing, the additive manufacturing side, and how that was brought to Metalmite. Again, that really focused on your joining the team a few years ago. I remember you first coming in and talking about your medical orthopedic experience, and you started seeing advantages of 3D printing in that world for, and I'll let you speak specifically, but I think it was knees and hips, wasn't it, that it was being printed at that point?
Yeah, I mean, I think in medical device, the early applications really focused on more maxillofacial and some of the printers that are literally in the hospitals for printing when you have massive trauma to the skull and the facial area, because each of us are so uniquely shaped that they have to reform that in a unique shape so they can print a framework around which they can rebuild the bone. But very quickly, then people began to look at things like porous structures. So many knee and hip implants have a porous structure that normally is either put on with titanium plasma spray or use a sintered bead coating, but something to create a porous structure so you get bone ingrowth, and then you get a mechanical bond between the bone that still is owned by the person and the implant. But now they figured out, rather than a two-step process of actually 3 and 4-step, manufacture, sinter on beads, then finish manufacturing, they could actually print the implant with the porous structure right on it. And so that was a growing area when I was in med device of use for the additive manufacturing. And of course, there's always the need for very quick turns that subtractive manufacturing just can't support. So somebody's in a development cycle, they want to do some testing on some joints, they want to do some testing on some initial surgical devices. What they'll do is they'll print them, because they literally can have them in 1 to 3 days, depending on complexity and post work. And those were the big things that were going on in med device.
And I think that's what I found interesting. I remember when you telling me some of these early stories. Initially, when 3D printing came on the scene, at least to my knowledge, around 25 years ago, the idea of 3D printing was to get a concept. A lot of that was SLA, this epoxy that forms into an image of the part. It was not a functional part, and it was not a very useful part, but it was inexpensive to create a 3D model and use it. But when I started hearing you talking about it in this medical device industry, what I found interesting is it wasn't just about cost savings or even time savings. You'd mentioned that it was because of this porosity that is important to the function of the part. And in some cases, you told me about parts that were 3D printed that couldn't even be made using the subtractive methods. Would you remember that specifically?
Of course, there are features that, as we all know, cannot be made with subtractive manufacturing, especially if you have internal channels and things like that. I do know that when you get into sintered bead coating, you are limited in terms of the size and shape of the beads, in terms of how large and the shape of those pores. You free up a lot of those constraints when you're going to 3D print it. As long as each layer has some part that's adhered to the layer before it, you now have some freedoms and some abilities to build some pore sizes and some structures that may not be achievable with sintered bead coating or titanium plasma spray.
Yeah, and if I remember properly, before you were in med device, of course, you were in aerospace. You were another customer of ours there. you had experience seeing them using, was it electron beam welding, where they were making some wing spars for the F-22 fighter?
Yeah, I don't remember offhand if it was the F-22 or the F-35, the Joint Strike Fighter, but I remember, yes, the company I was working for had a sister division, same parent company, that did electron beam free form fabrication, they called it. It was very rough in terms of nowhere near the precision that we're seeing, of course, in a medical device or something like that. But imagine a wing spar, this huge piece. Well, originally, those were giant blocks of titanium. The cost makes my stomach hurt to even think about. And then the hours and hours of hogging it. So you paid for all this titanium, and 90% of it ends up in the bottom of the machine, right, as chips. So hours of machining to throw away very expensive material. And what they figured out is they could lay, using electron beam and a spool of titanium wire, they could lay a rough shape of the part. Think about like a forging, only they were laying it down. So the titanium savings was huge. And then they would pass it to the company I worked for to do the machining, save dozens and dozens of hours per spar. If I remember right, the cost savings per wing spar was over $1 million between the titanium itself and the machine time.
Wow. So in that case, we are talking about a cost savings and potentially a time savings. So you do have both of those advantages of 3D. But then I know in aerospace, because we've had this conversation thousands of times, there's a big fear about the material, and can we verify the integrity of the material, and is it as good as something that comes from a mill? But as you and I both learned, in a lot of cases, an additive part actually has better integrity and more concrete properties. We've learned to print a dog bone alongside of a part and go ahead and let the test lab break it and do some testing. Were you able to see that as well in both medical and aerospace?
Sure. And that's part of the whole thing, right? It's change and it's new and it's different. So everybody hesitates. And of course, in medical, it's the FDA, and in aerospace, it's the FAA. So there's always going to be somebody making you prove it. However, there's ways that we prove it with subtractive manufacturing from bars that have inconsistencies and porosities and stringers and all kinds of issues that can exist in cold and hot rolled materials as well. And so there's no perfection. You can do the exact same kind of post-manufacturing inspections on a printed part that you can do on a subtractively manufactured part. So if that's the way you want to confirm it, it's possible. I've seen instances too where they actually either print a dod bone or keep a sample of the powder if it's a powder bed machine. All kinds of different ways they do that, so that after the fact, if there's any questions about effectiveness, we can always go back and test.
Yeah, so when you came on board with us and we had this history and experience you had just seen, one of the first things we did, of course, was send you to the additive show. I believe that was in Detroit that year. Do you remember going there and talking to some of the specialists? I think there was one of the keynote speakers was one of the leading, I don't remember if he was from MIT, but he was one of the leading PhDs in additive technology.
Yeah, fascinating things going on. For you sports nuts out there, one of the things that I had no idea was additive manufacturing was being used for was actually the internal structure for safety in the football helmets being used by all the pros. They've done all kinds of studies, and so they designed this thing to be able to have some give from the impact perspective, but protect the skull. And obviously concussions are a big deal these days. I thought, just a fantastic application that I was completely unaware of, but they can do that uniquely to each individual because of the shape of the head. So that, of course, we talked about a second ago, there are some parts that are not manufacturable with subtractive. So I saw some really fantastic examples, internal channeling, fluid channels that go around and intersect that you could never put in that are allowing. So what's happening now is we now have a young, new group of engineers who are cutting their teeth with additive. They're now thinking about designing a part for additive. And that's, it's a total mind shift. Right? If you think about somebody who's trained to design a product that's made of parts that can be manufactured from subtractive manufacturing, we've constrained their design right out of the gate. That constraint doesn't exist anymore. And so I saw a lot of fantastic examples of that, as well as even some, I wouldn't say millions and millions, but some relatively high volume manufacturing where they're building throughout the whole cube and then capturing samples throughout the cube. So they've got test sets. So one of them was, I don't know that I can mention the automotive company's name, but some relatively high-end vehicles. And they had a very unique part that was very difficult to make. And they were printing them for their production vehicles and then capturing samples all throughout the build. So that if there's ever a question about integrity, they could not only test a sample from that build, but from that area of the build, because every part was uniquely numbered. You knew exactly where it came from within the build.
Interesting. So in high volume production for automotive, we're seeing 3D printing on vehicles today, huh?
Yeah, so it was tens of thousands, I think, is what they were getting after, because this was a pretty high-end vehicle. It wasn't like my F-150 where they're going to make 2 or 3 million this year, but it was relatively high. Like I always thought of additive as much more niche and low volume and prototype, but they were definitely opening it up to production.
And so, of course, that show and that experience led to our first purchases at Metalmite back in 2018. Where you had found some of your connections from the medical field had a great deal on some machines. And so, of course, we brought it in and we've started our in-house printing since then. And now we're up to 7 printers with our print farm. So again, we've used the technology for years with suppliers outside. We've brought it in-house here the last 3 to 4 years, and it just continues to grow in our own uses. I know we're getting sensitive on time here. We promised everybody we'll keep it 20, 25 minutes. I did want to end with a couple current events, if you will. If we can do a throwback to our school days. As I was looking around in industry, I found a few articles here that we're so into the manufacturing world that we're making either parts for customers, fixtures and tooling for ourselves, and we're finding some unique. We'll get into this in a future show, but we just printed some things out of a rubbery silicone type product. So we're finding our own uses in our industry, but as 3D printing in general is being used in the world, I found it really interesting. And all these notes will be on our notes page at 3dfromnothing.com. But we have some medical testing going on right out of 3dprintingindustry.com. It says, together with several research institutions, companies across the region, Readily 3D will play its part in 3D printing a living model of the human pancreas in a bid to improve the testing for diabetes medication. Specifically, the company will be signing on as the project's official bioprinter manufacturer, adopting its proprietary contactless tomographic illumination technology to suit these particular needs of pancreatic tissue. What I found shocking there is we start talking about living tissue. They're actually printing and creating human organs in order to do medical testing on it. That was something, at least in my world, that blew my mind. Had you ever heard of anything like that?
I haven't heard of printing living tissues, but if they're finding ways to do that, of course, as we all know, unfortunately, pancreatic cancer doesn't have a cure of any type that we know of. There's no chemotherapy or radiation to cure pancreatic cancer. So if they can begin to use these sorts of things in ethical ways to study how they can stop some of these things, I think that's beautiful.
Yeah, and another article that popped up, again, I'll have a link to it. It was imeche.org news, but it's talking about in the future, pharmaceutical companies will be able to bypass the time-consuming pre-human stages, enabling this technology of bioprinting, the 3D printing of living cells and other materials to create biological tissue and organs. The article goes on to talk about they're actually using this now in COVID research. It says by using human cells in the printers, such as the NovoGen Bioprinter, researchers can replicate targeted tissues throughout the body, such as skin or liver tissue. You have it exposed to viral particles, bacteria, and the drugs before the microscope and other observations. So again, obviously at this current time frame, the time we're recording this, we're a year into the COVID international pandemic, and we have a few vaccines out there, but now they're actually using 3D printers for the testing of different medicines. And so in multiple ways, this is helping us because instead of testing these things on live humans, we're testing it on something we can 3D print. So again, I found that quite amazing to learn about that.
Yeah, I think the opportunity to bring things to market more quickly and without putting additional humans at risk presents some fantastic opportunities. Of course, we'll need to be very careful on the ethical side with all of those things. But I think, again, if they're monitored carefully, I think these can be great breakthroughs.
Yeah. Yeah. And then we get into the interesting side here. I know when I was sharing these links with you, your first thing is, what are you sharing this for? So as we find out we're printing living tissue to help in the medical advances, this article pops up out of The Sun. I believe it's a newspaper out of the UK. Again, the link is on our webpage here. KFC is working with a Russian 3D bioprinting company to create a lab-produced chicken nugget. The fast food giant announces it's the meat of the future concept, and it plans to have the product ready to test by the end of the year. Unfortunately, it sounds like they probably will be testing that on live humans, but KFC says in a statement they'll be taking the next steps in its innovative concept by creating the restaurant of the future. So I'm picturing, I think my wife said the Jetsons cartoon when we were kids, or the 3D printing your breakfast and your lunch and dinner here. Yeah, there's actually some videos, a link if people are that interested, they can check it out. It's interesting to me. They have 3 different vials and it's all natural, vegetable-based substances, and they're printing it to look like a chicken nugget, but I'm sure it's like a black bean burger or one of these Impossible burgers. But yeah, when we talk about 3D printing, I had not thought about chicken nuggets. So it's a whole new joke if you want fries with that.
Exactly.
And then the last part, again, the chicken nuggets is one thing, but a 3D printed steak. Again, there's actually a YouTube video we've linked to this one. An Israeli startup claims to have invented the world's first realistic 3D printed steak, all made from non-meat products. According to the information provided to the company by Reuters, in the media line, Redefine Meats is the alt meat made out of a combination of soy and pea protein, coconut fat, sunflower oil, along with natural colors, flavors. The company is based just south of Tel Aviv. It's worked with its butchers and others to digitally map more than 70 sensorial parameters, which includes the cuts, texture, juiciness, fat distribution, and mouthfeel. So I watched this YouTube a little bit, very interesting. They actually studied, there's this whole science of studying the marbling of a good steak and where the fat and they actually created a solid model and a blueprint of the perfect steak, and they're able to exactly replicate it every time. Pretty interesting. Again, not something I had thought of. I like traditional steak, but it's interesting to think about the 3D printed steak, right?
If 3D printing part doesn't work out, at least with the model, maybe we can grow a cow that's perfectly marbled.
Yeah, now we're getting into those ethics things. Exactly. Again, thanks for joining us, Patrick. Today's podcast, I found it very interesting. Hopefully our listeners did as well. We hope that you guys enjoy these podcasts and that you find value and you come away with learning something new. We appreciate the time you spent with us today, and we look forward to sharing with you more next time.
Thanks, everyone.
All right, I appreciate it. A little bit over our time, but it sounds like Zoom didn't kick me off. So see if we can work with that. All right, I'll see you in a little bit.
Sounds good, Tom. Thanks.
Thanks.